Hello students, in this video you will find structure of atom, Rutherford's atomic model. First I will tell you alpha scattering experiment. Before starting this, some basic point. First, what is alpha particle? What is alpha particle? Alpha is represented by helium, charge is 2 plus, positive 2 plus unit charge, and mass is 4 unit, represented by He. These are also represented by alpha. Second point, fluorescent material. Fluorescent substance. Fluorescent substances are those substances which convert here kinetic energy to light energy. They produce fluorescence, flash of light, illumination when alpha particle strike the substance. And these are some important points which I am going to use there. Now let us see alpha scattering experiment. Alpha scattering experiment. In 1911, Rutherford bombarded alpha particle on gold foil, thin gold foil of thickness around 0.006 centimeters to 0.004 centimeter thickness. The gold foil was surrounded by a circular screen coated with a fluorescent material, zinc sulfide. It was carried out in a evacuated chamber, and he observed. Now see, experiment was like that. Here first, suppose this is a gold foil, and this gold foil was surrounded by a screen. The screen was coated with a zinc sulfide substance, fluorescent material. This was coated with fluorescent material, and here this is fluorescent material coated with that. Now he bombarded this gold foil with alpha particles. These are alpha particles, and coming from radioactive substance. Here is a radioactive substance enclosed in a lead block, a radioactive substance, lead block, and this is a radioactive substance. Radioactive substance, and there is a lead plate with hole, and this is a lead block, radioactive substance. This is a hole in the lead plate, and this is a gold foil. Gold foil. When alpha particles were bombarded there, then he observed about 99.9% alpha particles passed through the gold foil without deflection and produced scintillation on the zinc sulfide coated screen. Scintillation means flash of light on the zinc sulfide screen. And Here like that, some particles like that. These particles were deflected from their path. Here scintillation was produced like that. Scintillation was, some particles were deflected like this, and some were going back like this. Now, Rutherford observed that 99% alpha particles pass through the gold foil without deflection from their path and produced scintillation, flash of light, bright spot on the zinc sulfide screen. From this flash of light, from this scintillation, number of alpha particles also can be counted. How many are striking there? Another thing, very few alpha particles deflected from their path and diverged, and a few alpha particles deflected back through an angle greater than 90 degree, and some alpha particles deflected, scattered at an angle of 180 degree. Now, from this observation, 99.9% passed without deflection, and very few deflected from their path and diverged, and a very few deflected back at an angle greater than 90 degree, and some scattered at an angle of 180 degree. Now, from these observations, Rutherford concluded some point. First point he told, remember these things. First point, most of the space in an atom is empty or hollow. This is why most of the alpha particles, more than 99%, can pass through it. And second point, he concluded that very few alpha particles deflected from their path and diverged. It proves that here in the central part of an atom there is positive charge, and another one, some alpha particles deflected back, some scattered at an angle of 180 degree. It means in the central part of an atom there is a heavy, dense part, heavy part. Central part is very heavy, dense. Alpha particles could not penetrate, and they deflected back in the same direction towards the source. Now, from this conclusion, 3 points remember. Most of the space in an atom is empty or hollow. Second one, the central part of an atom contains positive charge. And third one, entire mass of an atom is present in the central part of the atom. And fourth, he concluded that the central part of an atom where whole mass and positive charge is contained is called a nucleus. Now, with the help of this conclusion, he gave his atomic model in 1911 from this experiment. Then let us see Rutherford's atomic model. Rutherford's atomic model. Rutherford's atomic model. First, as I told you, most of the space in an atom is empty or hollow. Like this, according to Rutherford concept, suppose this is an atom, then most of the alpha particles passed through the atom without deflection, like that, and some alpha particles deflected back like this. Deflected back like this, and some alpha particles, they were retraced like this according to Rutherford concept. Then first point in his atomic model, remember first point, most of the space in an atom is empty or hollow. This is called extranuclear part of the atom according to Rutherford's model. Second point, positive charge, entire positive charge is present in the central part of the atom, and entire mass is also contained in the central part of the atom. This central part of the atom where entire positive charge and entire mass is present is called nucleus. This is the densest part of the atom. Third point. Now fourth point, let us see. The size of the nucleus is very small when compared to the whole volume size of the atom. Size of the nucleus is very small, in the order of 10 to the raised power minus, what is its size? 10 to the raised power in the order of 10 to the power minus 13 centimeter, whereas size of the atom is 10 to the raised power minus 8 centimeter. This atom size. Then size of the atom is 10 to the power 5 times heavier than the size of the nucleus. Hence size of the nucleus is very small when compared to the size of the atom. Next point. Electron revolve around the nucleus like our Earth planet revolve around the sun, and hence the motion of electron is planetary. Next point, these electrons revolve around the nucleus at large distances with each other and also from the nucleus. Next point, the force of attraction between nucleus and electron is balanced by a centrifugal force. By which force? Centrifugal force. Centrifugal force produced by the high speed of electron. Then force of attraction between nucleus and electron is balanced by the centrifugal force produced by the this motion of electron along the circular path. Motion of electron along the circular path. Atom is electrically neutral, as the total positive charge on the nucleus is exactly equal to the number of negatively charged particles, electrons present in the nuclear part of the atom. This is the Rutherford's atomic model. That's all for today. Again, next video you will find other interesting topic of this chapter. Thank you.